So in this video, I want to talk briefly about programming our second project, which is a projectile motion program. If you look at the animation up there, you see the little red ball traveling from the top of that yellow tower and then landing on the ground, and then it displays all the information. Um, and we'll take a look at the procedure down here. We're going to do some calculations. All right. But first of all, we need to copy the code. So if you go to this link, it should take you to a Google Doc, which I hope you can actually copy and paste the code out of. If not, you may have to share it with one another, but let's go do that. So I'm just going to go edit, copy. Then I'm going to switch over to web or glowscript.org, log in, and create a new program. I'm going to call this Projectiles, or maybe just Projectiles 03.02. And hopefully, with a little bit of luck, paste our code in. Now, I think I may have gotten, I do have two web Pythons up here. Let me take out the top one here. There we go. And so if you look at the code here, we set the initial launch velocity, the initial angle, and the initial height. But down here, we need to calculate the initial v sub x, that's the horizontal velocity, and v sub y. To do that, let's take a quick look back. I might get rid of that. Look back at the instructions. We can use math.sine and math.cosine to figure out those portions. But there's one little issue on this one. These require this to be expressed in radians. So to convert to radians, we can multiply degrees by pi and then divide by 180. So let's do that real quick. And my apologies, I can't draw graphics on here real quick. But if you think about a triangle, and I wish I could draw in some way on this, we've got a launch angle like this. To find the horizontal, that's the adjacent side, I'm going to need to do cosine. So I'm going to take the variable here called launch velocity and copy paste it, or you can just type it down. And I need to multiply that by math.cosine of the angle. The angle up on top is listed as angle, but I'm going to need to divide that by 180 and then multiply by pi to convert that into degrees so that it's actually somewhat friendly for the program. I'm going to do the same exact thing for the vertical component, except instead of cosine, I'm going to use sine. So I'm just going to go back here, delete cosine, and do sine. Same angle, divided by 180 times pi should convert that to radians, so it'll work. Let's just double check, make sure the program runs at this point. Oh, sure enough. And so we've got our projectile being launched, and it's going quite high. Oh, wait, there's no gravity. All right, hold on a second. Let's take a look at this. In the set initial variable section, modify the acceleration vector so the acceleration of gravity is negative 9.81 in the y direction. Again, normally we use negative 10 for AP Physics 1, but let's try to make this one a little bit more precise. Those three numbers represent the acceleration in the x direction, the y direction, and the z direction. In this case, we want it so that the acceleration's in the y direction. So let's go back to the code. Where is the acceleration set? Oh, we don't have it set. All right. Oh, here it is, down here. Set initial variables. So right down here in the y part, we want to set that to negative 9.81. And I can take out the spaces just so it looks prettier. Doesn't have to be that way. All right, so now the acceleration is going to be this much. No acceleration in the x direction, no acceleration in the z direction. Just that. All right, let's run the program real quick and see what happens. There we go. Now it's actually accelerating downward. It's falling, which is what we want. All right, back to edit the program. What's our next step? Add one more print statement at the end of the program that will print how far away from the tower it landed. It should have a form. It landed so many meters from the tower. Hint, remember the distance will be equal to the horizontal velocity multiplied by the time of flight. All right. let's go down here for a second. Okay, so we already have this part right down here. We just need to add another print statement. Print. It landed, and then we have to comma here, and then we need to calculate how far away it landed. That's going to be the horizontal velocity, which we called v sub x, and that's capital V sub x, times the time. T is the variable here that shows how many seconds it took to hit the ground. Actually, I'll put a space in there. Hopefully we can do that multiplication in there. Sorry, I got to look at the form that they want this in. Meters from the tower. So quotation marks, and again, make sure you get the right one. Put a period there, and then close parentheses for that. Let's see if that works real quick. If not, we'll have to calculate outside. So here it goes, and when it hits, if our print statement's right, it should list all the information. Yeah, good. Ball was launched at 50 meters per second, angle of 43 degrees from a height of 100 meters. It hit the ground at 9.17 seconds and landed that many meters from the tower. Good. All right. So our last step on this one is modify the program so it accepts user input from the launch for the launch velocity, angle, and initial height of the ball. Hint, modify the set initial condition sections to use input statements instead of fixed values. Take a look at the vector addition program if you need help writing these input statements. So on this one, up here right now, these three things up in initial conditions are already preset for us. So what we need to do is go back and let's take a look at our vector one, just so we can sort of take a quick look at it. To get input, oh, we don't even have the input statement on here. In my code, shoot. All right, no worries. We'll figure this out. So for the projectile, let's try this. So instead of doing launch velocity equals 50, let's do launch velocity equals, I'm going to keep, well, all right, let's just change it. Oh, hold on a second. Let me just take a quick look. I'm going to go back and look. I can't remember the format of this one. Let's take a look at the vector program real quick. How do we get the input? And I'm afraid, oh, okay, it's float input. All right, I'm going to copy this and then go back to our original code down here. So I'm going to paste that in. I'm hoping you can do that too. Enter the launch velocity is what we want to do. So it'll prompt the user for that, and then they can simply put in a value there, and that should work. And I'm going to borrow that same statement here and use it for the angle. Enter the launch angle in degrees. Now, I'm just putting degrees there so the user knows. And finally, float input, enter the initial height. And I guess, I don't know if we should put, let's go ahead and put in meters in that one. If I do that, let's put a little meters per second here, just to prompt the user so they know what units we're entering these in. I'll take out the space here. Let's see if this works real quick. Run this program. Launch velocity, let's go 100 meters per second. Angle, 45 degrees. And the height, let's say we're shooting it from 10 meters. And there it goes. Wow. It's going to go a long distance. It's probably going to go off the screen. It's probably going to land off of my surface. I probably should make that bigger. And there it is. It's going to take 14.555 seconds, and it's going to land a kilometer away from the tower. Hopefully you get this working. If you want to, you can actually make the ground a little bit bigger. Where is the ground? It's right here. Right now it's 500. I probably should make it, at least to run that program, I probably should make it like 1,200 meters. And I just made it a rough surface. You could change it to something else. With that, hopefully this program will work for you. Good luck, and talk to you soon. Bye.